Hey everyone, and welcome back for another deep dive. Today we're going to be talking about something pretty amazing. Um, a brand new galaxy.
Oh yeah, this one's really cool.
It's a dwarf galaxy. And it's so faint that it almost completely slipped past our telescopes.
Yeah, it's really pushing the limits of what we can observe. It's like finding a needle in a cosmic haystack.
That's a great way to put it.
Yeah.
For those of us who don't spend all of our time looking up at the stars, can you give us a quick reminder about what a dwarf galaxy even is?
Sure, yeah. So basically they're like the little siblings of the larger galaxies, like our own Milky Way. So they're much smaller, they're fainter, they have fewer stars, and they're thought to be kind of like leftovers from the very early universe.
So like cosmic time capsules, why are they so important to astronomers?
Yeah, exactly. They give us incredible insights into how galaxies form and how they evolve over time. And they're also thought to be packed with dark matter.
Ooh, dark matter. That's always so interesting to me. So, back to this new galaxy. What's its name? And how did we even find it if it's so faint?
So it's called Pegasus VII. And you're not going to believe how we found it. It was basically hiding in plain sight.
Really?
Yeah, so astronomers, we're looking at data from this survey. It's called the Ultraviolet Near-Infrared Optical Northern Survey. UNIONS for short.
Catchy.
Yeah, so it's basically this massive survey of the northern sky.
Okay, so like a treasure map, but for space.
Exactly. Yeah, and during this survey, they noticed this tiny little smudge of light near our galactic neighbor Andromeda.
Okay.
And at first they weren't sure what it was, but they pointed some of the world's most powerful telescopes at it, like the Canada-France-Hawaii telescope and the Gemini North telescope, and bam, there it was, brand new galaxy.
Oh, wow, talk about a needle in a haystack. So how faint are we talking? Can I see this with my telescope in my backyard?
There's not a chance.
Yeah.
Imagine the faintest star you can barely see on a clear night. This entire galaxy is that faint. Millions of times fainter than anything you could see with the naked eye, even under perfect conditions. That's why we needed these specialized telescopes to confirm it.
It's amazing to me that something that faint can still be a whole galaxy with its own stars and planets and everything. So where's this galaxy?
Yeah, so it's about 2.4 million light years away from Earth, which puts it pretty much in Andromeda's backyard. So Andromeda is like this big, bustling galactic city, and Pegasus VII is like this tiny, almost invisible suburb on the outskirts.
I like that. I like that analogy. And because it's so far away, the light that we're seeing from it now is 2.4 million years old.
Yeah.
So we're basically looking back in time. What else do we know about this galaxy?
Well, based on its size
Yeah.
and the types of stars that we see in it, astronomers estimate that it's about 10 billion years old.
10 billion years old.
Yeah.
That's almost as old as the universe itself. What do you think those ancient stars have witnessed over all that time?
It's incredible to think about. And here's another cool thing. This galaxy is really, really small. It has a mass that's only about 26,000 times that of our sun, which is tiny compared to a giant like the Milky Way, which has hundreds of billions of stars.
So it's ancient, it's faint, it's tiny, and it's lurking around the edges of a much larger galaxy. It's already shaping up to be a very interesting character. But what I think is really cool is that this discovery, it's not just about finding a new galaxy. It actually has implications for how we understand the entire universe.
Yeah, you're exactly right. This is where the story of Pegasus VII gets tied to.
Some of the biggest mysteries in astronomy, like galactic evolution and the nature of dark matter. Okay, I'm hooked. Let's unpack those. Starting with galactic evolution. How does the discovery of Pegasus VII fit into the grand scheme of how galaxies form and change over time?
Well, the current theory is that large galaxies, like Andromeda, they grow over billions of years by attracting and absorbing smaller galaxies, like Pegasus VII. This is known as the hierarchical model of galaxy formation.
So Andromeda is kind of like a cosmic Pac-Man, gobbling up any dwarf galaxies that get too close.
Well, it's not exactly gobbling. It's more like a slow gravitational dance. As a smaller galaxy gets closer to a larger one, the larger galaxy's gravity starts to pull on it and distort its shape, and eventually pull it apart.
So it's more of a merger than a hostile takeover. But you mentioned that Pegasus VII is also giving us clues about dark matter. Could you explain why this tiny galaxy
It's so important.
for understanding this invisible stuff?
Yeah, so remember how I said that dwarf galaxies are thought to be packed with dark matter? Well, Pegasus VII is no exception. In fact, it might be made almost entirely of dark matter.
Wait, so you're saying that this whole galaxy is mostly made up of something that we can't even see?
That's right.
How can astronomers even tell?
That's a great question, and it brings us to one of the most important tools that astronomers use to study dark matter. It's called the mass-to-light ratio.
Okay, break that down for me. What is a mass-to-light ratio, and what does it tell us about dark matter?
Okay, so imagine you have two boxes that look identical, but they have very different weights. The heavier box clearly has something else inside it, even though you can't see it. That's kind of like the mass-to-light ratio. It compares how much mass a galaxy has to how much light it gives off. If a galaxy is really dim, but it has a lot of mass, that means there's something else there,
Yeah.
contributing to the mass, that we can't see. Something like dark matter.
So a galaxy that's faint but heavy is a strong indication that it's full of dark matter.
Exactly. And Pegasus VII is one of the faintest galaxies we've ever discovered. Yet it still has enough mass to hold itself together. So that means there must be a huge amount of dark matter lurking within it, influencing its gravity.
Wow, so this tiny, faint galaxy, millions of light years away, might hold the key to understanding one of the biggest mysteries in the universe.
It truly is, and that's just the beginning. There's still so much more to learn about Pegasus VII and what it can teach us, about galaxy formation, dark matter, and the evolution of the universe.
Okay, I'm on the edge of my seat here. Let's take a quick break to let all of this sink in. And when we come back, we'll explore the implications of this discovery in even more detail. Okay, we're back, and
Nope.
I'm still trying to wrap my head around a galaxy that's 10 billion years old, that's older than our own solar system.
I know, it's incredible.
It really is amazing that we can even find something so faint and so far away.
Yeah, and you know this discovery, it could just be the tip of the iceberg. There could be countless other dwarf galaxies out there just waiting to be discovered.
That's both exciting and terrifying to think about, right? Like
Yeah.
the universe is so much bigger and more mysterious
Yeah.
than we often realize. But before we get lost in the cosmic abyss, let's talk more about Pegasus VII and how this discovery helps us understand galactic evolution. You mentioned this cosmic dance between galaxies earlier.
Right, yeah. So Pegasus VII is a perfect example of that dance in action. You know, it's elongated shape. It's a telltale sign that it's been interacting with Andromeda's gravity for billions of years.
Oh, wow.
It's like Andromeda is gently tugging at it,
Yeah.
stretching it out over time.
So it's not a peaceful merger then, but
Yeah.
more of a gradual process of one galaxy being pulled apart by another.
Exactly. Astronomers call this tidal disruption. And as Pegasus VII gets closer to Andromeda, this gravitational tug-of-war will only intensify. Eventually, it's possible that Pegasus VII will be completely absorbed into Andromeda, adding its stars and remaining gas to Andromeda's halo.
Wow. It makes you wonder how many other galaxies have met a similar fate throughout
Wow.
cosmic history. I mean, it kind of puts our own galaxy's future into perspective, too.
It certainly does. You know, our own Milky Way is on a collision course with Andromeda billions of years from now. So in a way, studying Pegasus VII gives us a preview of what might happen to our own galaxy when that cosmic merger eventually takes place.
Talk about a long-range forecast. So let's shift gears a bit
Mhm.
and focus on the technology that made this discovery possible. I mean, finding something as faint as Pegasus VII must require some seriously cutting-edge tools, right?
Oh, absolutely. This discovery wouldn't have been possible without the incredible advancements we've made in both telescopes and data analysis techniques. So the initial detection of Pegasus VII came from the Union survey, which uses a combination of telescopes to capture a wide range of light, from ultraviolet to near-infrared to optical.
So it's like having multiple sets of eyes, each sensitive to a different kind of light, scanning the skies for anything unusual.
Exactly. It's like casting a wider net, allowing astronomers to spot things that might have been missed with traditional telescopes. And once they found that initial smudge of light, they needed even bigger and more powerful telescopes to confirm that it was actually a galaxy.
And that's where telescopes like the Canada-France-Hawaii telescope and the Gemini North telescope come in.
Yeah.
What makes those telescopes so special?
Well, these telescopes are like the heavy hitters of astronomy. They have massive mirrors that collect far more light than smaller telescopes, allowing them to see much fainter and more distant objects. They're also equipped with incredibly sensitive instruments that can detect tiny variations in light, which is crucial for studying the properties of galaxies like Pegasus VII.
So it's like having superpowered vision that allows us to peer into the depths of space
Yeah.
and unravel the secrets of these distant objects.
You got it. But it's not just about the telescopes themselves, it's also about the data. The amount of data that these surveys generate is absolutely mind-boggling. We're talking terabytes upon terabytes of information.
Wow, so how do astronomers even begin to make sense of all that data? I mean, it would take a lifetime to go through it all manually.
Yeah, that's where the magic of computer algorithms and artificial intelligence comes in. Astronomers use sophisticated software that can sift through mountains of data, looking for patterns and anomalies. That might indicate a new discovery, like a faint galaxy hiding in the background of a star field.
So it's like having a team of digital detectives working around the clock, looking for clues that we humans might miss.
Exactly. These algorithms can analyze data much faster and more efficiently than humans ever could, allowing astronomers to find hidden gems like Pegasus VII that might have otherwise gone unnoticed. And as our computing power continues to increase, who knows what other incredible discoveries await us out there in the vastness of space.
That's what makes astronomy so exciting, right? There's always something new to discover, and the tools we use to make those discoveries are constantly evolving.
I couldn't agree more. Each new finding pushes the boundaries of our knowledge and opens up a whole new set of questions.
Okay, so we've covered a lot of ground here, but we still need to tackle the elephant in the room. Or should I say the invisible elephant in the room? Let's finally dive into the details of what Pegasus VII is revealing about dark matter. Okay, so it's time to tackle that big invisible mystery that's been looming over our conversation, dark matter. We've been dancing around it, but now I'm ready. To dive headfirst into the deep end, what is it about Pegasus VII that's making astronomers so excited about understanding dark matter?
Well, as we touched on before, dark matter is this elusive substance that doesn't interact with light, it doesn't emit it, it doesn't absorb it, it doesn't reflect it. It's basically invisible to all of our telescopes.
So how do we even know it exists? I mean, it sounds like something straight out of science fiction.
Well, it might sound strange, but we know dark matter is out there because of its gravitational effects on the things that we can see, like stars and galaxies. So think of it this way. Imagine you're watching a puppet show, but you can only see the puppets. You can't see the puppeteer. You know someone is controlling those puppets, even though you can't see them directly because of how the puppets are moving.
Okay, I see that analogy. So we're seeing the effects of dark matter's gravity, even though we can't see the dark matter itself.
Yeah.
But how does Pegasus VII fit into all of this?
Well, Pegasus VII, like a lot of other dwarf galaxies, is thought to be dominated by dark matter. It's like this giant clump of dark matter.
Yeah.
With a sprinkling of stars and gas mixed in.
So you're saying
Yeah.
that this faint little galaxy could actually be mostly made up of this invisible stuff.
Yeah, that's right.
That's pretty wild. But how can astronomers be so sure about that?
Well, it goes back to that mass-to-light ratio that we were talking about earlier. Remember, it's like comparing the weight of two boxes that look identical. Pegasus VII is incredibly faint, which means it doesn't have a lot of stars giving off light. But it still has enough mass to hold itself together as a galaxy, which means there must be something else there, something we can't see that's providing that extra gravity.
And that something else is dark matter.
Exactly.
It's like the invisible glue holding this whole galaxy together.
That's a great way to put it. And because Pegasus VII is so faint and relatively isolated, it gives astronomers this really unique opportunity to study dark matter in a more pristine environment. It's like a natural laboratory for dark matter research.
Okay, I'm starting to understand why astronomers are so excited about this discovery. It's like they've stumbled upon this cosmic treasure chest full of clues about dark matter. So what specific research are they actually doing with Pegasus VII? What are they hoping to learn?
Well, one area of research is trying to map the distribution of dark matter within Pegasus VII. By studying the motions of stars within the galaxy, astronomers can get a sense of how much dark matter is present in different regions and how it's clumped together.
So it's like using the stars as tracers to map out this invisible landscape of dark matter.
Exactly. It's like using the stars as little beacons to illuminate the dark matter's gravitational influence. Another area of research is looking for indirect evidence of dark matter interactions. While dark matter itself doesn't interact with light, some theories suggest that dark matter particles might occasionally collide with each other and annihilate, releasing energy in the form of gamma rays.
So if astronomers detect gamma rays
Yeah.
coming from Pegasus VII, that could be a sign
Yeah.
of dark matter particles interacting.
That's right. It would be a major breakthrough. Detecting these gamma rays would provide even more evidence for the existence of dark matter, and it could give us valuable insights into the nature of dark matter particles themselves.
This is all so amazing. We have this incredibly faint ancient galaxy millions of light years away, and it's helping us unlock some of the deepest mysteries of the universe. It really makes you wonder what else is out there, hiding in the darkness, just waiting to be discovered.
I know, it's incredible. That's the beauty of astronomy. There's always something new to explore. And with each new discovery, our understanding of the universe expands, and we're left with even more questions to ponder.
It's humbling and exhilarating at the same time to realize how much we still don't know about the universe,
Hmm,
but to also be a part of this ongoing quest for knowledge.
I couldn't agree more. And who knows what amazing discoveries await us in the years to come. With new telescopes and new technologies constantly being developed, the future of astronomy is incredibly bright.
Well, this has been an incredible journey, this deep dive into Pegasus VII, and I hope all of you listening out there feel that same sense of wonder and excitement that we do. Remember, the universe is full of mysteries, and with every new discovery, we take one step closer to unraveling them. Keep looking up, keep exploring, and who knows what incredible secrets you might uncover. Until next time, keep those cosmic questions coming.